Okay, so this video is on chemical reactions, and you should have a little bit of an introduction of what chemical reaction is from the simulated lab from yesterday. So I suggest making sure you've completed that before you complete these notes. In your notebook, you're just going to take the page and separate it into like 6 squares. You can turn it sideways if you want to so that it's long ways like this. That's what I suggest. But if you want it, vertical, that's fine too. Just however you want to divide up your notebook so you have 6 pages. Okay, and then we're just going to label it chemical reaction notes. And it might be better if I'll try to center that. There we go. All right, so in this first center square where we have our title, there's a couple of, vocabulary that we need to know. So we're going to write down 2 words, and those are reactants and products. Okay, so in any chemical equation, which you saw in the simulation, you always have reactants, right? And reactants is what you start with. So we'll just say what you start with. These are like the ingredients, okay, for a recipe. Okay, because cooking is actually a chemical reaction. That's what's taking place. You're changing, right, those ingredients into something new. And so our reactants are what we're going to start with, all right? And if that's, if the reactants are what we start with, then our products are what we end with, okay, or what we produce, okay, from our reaction. All right. So we have reactants and we have products. So as we go through, we're going to talk about different types of reactions. And what I'm going to do is I'm going to color code my notes so that I'm always writing my reactants in blue and I'm writing my products in orange. So I suggest you figure out some way to also color code your notes, or if you feel like you can just remember, that's fine. But at least if you're color coding, 1 or 2 of the reactions, that will just help you as we go through different notes and things. So let me see here. I want to choose a different color just because I like different colors. All right, so the first type of reaction we're going to talk about, okay, is a synthesis reaction. Okay, synthesis. So when we think about synthesis reactions, I think about the word synthesize or to make something. A lot of times when you're saying synthesize, you're talking about how you're taking lots of different things and you're kind of turning it into one or making one thing, combining. So sometimes you'll see synthesis also written as combination reaction. Okay, and what this is just where 2 or more reactants, okay, I'm just going to abbreviate that, reactants, combine into one product. Okay. And so what I'm going to do is I'm going to write a sample equation. Okay, A plus B. We'll just do that. And then remember my products are in orange. And so I'm going to write it like AB where it's combined. So here I can see I've added 2 different things and I've combined it into one. Okay, my next type of reaction, it's called decomposition. So if you've taken biology, right, when you think about decomposition, you might think of decomposing, right, or breaking down. So this is when one reactant, reactant, not reaction, sorry, one reactant breaks apart into two or more products. So this is basically the opposite of synthesis. Okay, so there's my reactant. Okay, and then my products, right, I'm breaking it apart. So instead of just one compound, I have two different substances. Okay, so anytime you see, here, we'll just make like a little note here, right? Anytime you see two things that are together, this means they're bonded together. So, right, so this is a compound. Anytime you see things stuck together like that, right? So notice over here in my synthesis, my bonded compound is my product. And in decomposition, my bonded compound is my reactant. All right, so make sure you can't flip-flop those just because you want it to be on one side. All right, if my bonded compound is my reactant, that means I have a decomposition reaction. Okay, I can't change it to something else, or I can't call that a reactant because, or a product, because it's a product in synthesis, right? It's a different type of reaction. So when we're going through and looking at these, right, you're just kind of matching them up to these sample equations or kind of these pretend equations, so we can kind of match a real equation to a pretend one. All right, so we have a single replacement reaction, okay, and then our next one is a double replacement. So let's talk about both of these kind of together. Okay, I have single replacement and double replacement. So a single replacement, okay, this is where one element, okay, replaces one element in a compound. Okay, so let's see how this is going to work. So I have a reactant, A, and then I have BC. Okay, that's my reactants. And then if we look here, what's really going to happen, okay, we're going to have this A is going to come over here and kind of kick out B. So it's going to replace B. So now B is by itself, and I have AC in place. Okay, so you can see my B and A kind of swap places. With a double replacement reaction, instead of just having one element swapping, okay, we're going to have two elements swapping. So we'll say two elements from different compounds you can say either replace each other. Sometimes I just say swap places. Okay, we'll say or replace each other. Okay, so let's see what that means. So remember, this time I have two compounds. So we'll say C, D. Okay, and so this time, instead of just a single element kind of replacing and then being by itself, we're still just swapping in this one spot. Okay, ooh. We're still just swapping in that one spot, but it's called double because it's going to actually make two new compounds instead of just one new compound. So now instead of an A at the beginning, I'm going to have a C, B plus A, D. Okay, so you can see the C and the A swap places. So really the big difference here when you're looking at single and double replacement, single, right, I have a single element, single replacement, okay? For double, everything is doubled up, okay? Pairs, I have double and a double. Okay, so that's an easy way to kind of remember the differences between those. All right, the last one is a little bit different, okay? Combustion is where you have some type of fuel, okay? Fuel is just a carbon compound. I'll show you an example, okay? Is going to burn with oxygen, okay? So we always have to write it on fire. Oh, here, let me write out oxygen for you so that's not confusing. Oxygen, okay? And it produces carbon dioxide, CO2, and water. All right. And this is like a gaseous water, okay, like water vapor, O-U-S, gaseous. Okay, gassy, O-U-S, gaseous, like water vapor, okay? Or, like when you, like steam, when you boil water, right? That steam coming off, that's really still water. It's just in a gas form. So that's what we mean when we say here water. It's not liquid water. It's in a gas, okay? And so our formula is going to be a little bit different than these ABs. We're not going to use those. We're going to use actual compounds. So what you're going to see is you're going to see a CH, and there's going to be usually some numbers down here. We talked about subscripts. So CH4, it could be C2H6. Okay, it could be any kind of CH. So a lot of times what we do to designate that, any type of CH, is we put, a CXHY. So it doesn't really matter what numbers are down there, as long as you see the CH. Okay, and then we're going to say plus oxygen. Okay, so we write oxygen like O2. And then what we're going to end up making is, like we said, CO2 plus H2O, water. Okay, so I still have reactants and I still have products, but these are just more specialized. Okay, this is, anytime you see this formula, it's always combustion. I know it kind of can look, sometimes it gets confused with single replacement because we have a single element right here. But if you notice, you're not making a single element. You're making two different compounds, so it doesn't look like a single replacement reaction. This is like an example. Here, we'll write an example here. Like if you have a propane tank, okay, propane could be my fuel. If you ever, you have to light it on fire usually, right? It has to be kind of in air. It needs oxygen to burn, just like any kind of candle or flame needs oxygen. You probably know that. If you cut off the oxygen, the flame goes out. So this fuel, right, if you have like a gas grill or a home or a gas stove or anything like that, when you light the propane tank, right, it's going to burn a flame. Okay, and so what you're actually doing is you're creating a chemical reaction. Your propane eventually burns up, right? Well, what's happening to it? What's happening to it is it's turning into carbon dioxide and then gaseous water or water. Add about the combustion reaction is that one of the, I guess I'll put it in orange to kind of stay with the theme, but one of the major products is energy. Okay, so this is why, like when we were talking about when you light a propane tank, right, and it gets really hot. Well, the reason that it gets hot is because it's releasing energy. Your car runs on gasoline, right? Gasoline is a fuel. and it has, when you turn your car on, right, you have like your ignition switch is literally igniting that fuel. And that's why your car moves, is because it takes that energy that's produced from that reaction, from burning that gasoline, and then it can turn it into mechanical energy and electrical energy that is what powers your car. So just know that one of the major products of a combustion reaction is energy. That's why, it's also why anytime you have any type of flammable like fuel, it can be dangerous because it can cause an explosion, because it just releases so much energy in that reaction that the more you're reacting, right, if you have gallons and gallons and gallons of fuel, it's going to release more and more energy, or an explosion versus, a small amount.